Okay, this month we are going to talk about serialization and remote procedure calls with Cap'n Proto, which is an evolution of a library called Protobuf. You can find it on GitHub, and it is been out here for a while. They're still reporting a version number less than 1 for some features anyway. But the idea of Cap'n Proto is to provide a very efficient message and remote procedure call framework. Efficient in the sense that the number of bytes used to represent a message or a data structure across some communication channel doesn't have to be a socket, but it is typically a network socket. Could be a serial port, a serial communication, asynchronous RS-232 stream, could be a file descriptor. Cap'n Proto doesn't care. It doesn't care in terms of encoding the data and deserializing data from encoded form into a structure. It is a little bit different from what we looked at with boost serialization in that it has a so-called interface description language that you use to describe your data structures and to describe your remote procedure call interfaces. We will look in detail at that in a little bit. Excuse me. We are continuing with our comic book database example that we have been using for the past few months. We will see what that looks like in Cap'n Proto, how to adopt our existing data structures. So here on their GitHub page, you can see their code history. And you can see that there was some commits yesterday, so this is an actively developed project. They don't have too many outstanding issues. 444 closed, 129 open. That's good. That means that issues are not being ignored. It's not a good sign when you go to an open source project and the number of open issues is larger than the number of closed ones, or sometimes there are no closed issues, but only open issues, and that's also disconcerting. But Cap'n Proto is actively developed and maintained and worked on, so it is in good shape in that regard. The main documentation is on this capnproto.org website. There's an introduction here explaining how Cap'n Proto differs from Protobuf. The author of Cap'n Proto was one of the authors or the primary author for Protobuf. Protobuf is a very similar message and RPC system that was developed by Google. And not only is Cap'n Proto focused on an efficient encoding of data structures and requests and responses, the API is promises oriented. So that's what this little diagram here is trying to show us, that in traditional RPC, the client issues a request to the server does some work and returns an encoded response back to the client. And in this case, it's calling foo, and foo returns some object of X. And the next thing that the client does to the server is to make another remote procedure call passing X as an argument. Now, in this sequence of call chain, we had to get an X in order to make the method call in step 3, but we didn't do anything with the X between step 2 and step 3. We didn't query any data out of it. We didn't modify it. We needed to get one in order to pass it to the next method. So really, what we could have done, instead of returning the full serialized object in step 2 from the server, and then reserializing X on our end. Sorry, the server returns a serialized object, the client deserializes it, and then reserializes it in step 3 to transmit it to the server. The server then deserializes it again to begin processing the object. instead of doing that, since we didn't do anything with x between step 2 and step 3, we could return a promise for the value of x that's effectively a placeholder, and then the client could hold that promise, that placeholder, send it to the server in step 3. And that's what's being shown in this diagram on the right. That's what Cap'n Proto does, is that it immediately returns you a placeholder for the object x, which you can then say, I need the contents, in which case you would get that data deserialized from the server back to you. But if you didn't need the contents, you just needed to pass along to a subsequent method, then you would close those delay gaps and you get the picture shown on the right. So there's a comment in here, why does the author in this little introductory page pick on protocol buffers so much? And the answer is because he was the primary author of protocol buffers. Now, while you get this introduction page, and there's a page here describing how to install Cap'n Proto, I actually did it a little bit differently using VC package. I will explain what I did, and what I did is simpler, actually, because VC package took care of all the details. And they have a page describing the schema language that you use to describe your structures and your interfaces. We'll take a look at that in more detail in a minute. And then there's a page on the encoding, how data structures and parameters and responses from methods on interfaces are encoded. This is what ends up going over the wire if it's a network communication. And then there's a documentation page on the remote procedure call protocol, how that works out, and that has to do with how you describe an interface with methods and how those methods specify their parameters and their return types. We will look at this in a little bit more detail. A little bit of a discussion comparing this to Corba, the Common Object Request Broker architecture. That is the distributed object and interface standard that the non-Windows world adopted. The Windows world adopted distributed COM, which is basically a form of COM over the wire. Some talk about protocol features and security, and then we have a discussion of the Cap'n Proto tool. We will look at this as well in a little more detail, but this is the tool that you use to compile your interface description language into something that is source code for whatever language you're using. We will be using C++, of course, but there's also support for Python, I believe. I don't recall off the top of my head what other languages they support. Then there is, we're just reviewing what's available in the documentation here. There's a discussion of C++ serialization. So an example of, here's their IDL, and then here's some sample code in C++ that does reading and writing. In this case, it's doing to an integer-based file descriptor as opposed to a network socket. So it's encoding the data into a file on the disk and then deserializing from that encoding on the disk file. Some discussion about C++ 11 and exceptions. This library assumes C++ 14, so it's 11 with bug fixes is the way to think of it. There's a utility library underneath called this KJ library. There's some code generation we will have to do. We're going to do that in CMake. I will show you how that works. And it's possible to do namespaces in your IDL, so that can translate into, I believe that can translate into C++ namespaces or what have you. Discussion of the primitive types and what they turn into in terms of C++ data types. We will see what kind of types are supported in the IDL. Some discussion of how lists and enums and blobs of arbitrary size text and data are handled. Interfaces, little bit of messaging and I/O. You could use a memory mapped file as a way to communicate between different processes on the same system, or that can see the same file system. A little bit on dynamic reflection, some discussion down here of tips and best practices, and a little discussion about lessons learned from protocol buffers. And then finally we have a page on C++ remote procedure call and how the generated code interacts with that. There's a framework for creating a simple client and a framework for creating a simple server. This is what I used in my little working example. As you know, discussion about how to bootstrap your client up and get it talking to a server, how to get your server going and have it listening and accepting connections. And looks like other languages. So I knew they had Python support, but there's quite of other languages in here that have both serialization and RPC. So C#, Erlang, Go, Haskell, JavaScript, Python, as I mentioned before, Rust. And then there's some that have just serialization only. Now, that's the end of the documentation. So what you'll notice that's missing is a full-blown programmer's guide that covers all the features supported by Cap'n Proto, and there's no reference, no class reference, no Doxygen-generated reference. So that can be a bit of a challenge. You have to get familiar with drilling into code using your IDE and looking at header comments if there are any. There aren't necessarily header comments for everything, although there are comments sprinkled around. And a lot of the code is generic through the use of templates, so when you're drilling in, you're going to have to be okay with reading past whatever template-based class noise is present. You know, the template parameters don't reflect the actual parameters that you're using, so you have to translate in your brain from what you read on the screen as T to whatever type that you're actually using. And I'd say that's the most challenging part of using this library is, you know, it wasn't too difficult to figure it out. I mean, what you'll see in my example is what I've put together this afternoon. It wasn't terribly difficult, but I have a feeling that I wasn't necessarily using best practice. It was just what I managed to figure out from looking at the header files and figuring things out as best I can with code completion and browsing. Now, if we look over here in the GitHub repo, we see in the C++ folder, there is a samples folder, and the documentation does reference this. There's a address book example that reads and serializes and deserializes an address book to a file. And then there's a calculator client that's a client-server pair that does simple calculator evaluation of expression. The evaluation of the expression is done on the server, and the expression is sent from the client, and it reads the result back from the server and prints it out. And while that is useful for showing you some of the basics, it still falls short of a complete reference to show you how to do all the things that you might be able to do in Cap'n Proto, because not even every IDL feature is used in these Cap'n P files are the IDL files for the address book example and the calculator example. So while it's a starting point, but lacking a complete reference and a complete user guide. I mean, there's a lot of discussion over here in this of the RPC protocol and so on, but lacking full complete examples and lacking a full documented reference, you can get stuck at times and you may have to go to Stack Overflow. Now, this library's been around for a while, so there are people asking questions on Stack Overflow. when I was trying to figure out the things where I was stuck for a little while, I wasn't finding the exact answers to my questions. Could be I didn't phrase the question right, or and it didn't match the Google algorithm, or what have you. Now, I'm not saying this library is bad in any stretch. It's not. But those are some things that you can stumble on. Now, we've been looking at this comic book database example for the past few months, and I will just show you briefly how I've kind of teased it apart a little bit even further from previous examples. So what I have here is kind of a merge between the REST API version that we had. So I've split all the application logic out. So this is the comic book database part. This is the code relating to individual issue of a comics that are stored in the database. This is the code representing serialization and deserialization from JSON. And I've slapped that into a static library called comicsdb. And in this code, I just preserved the RESTbed HTTP REST API service that we had created earlier. It's gotten renamed. It's just been the code for that has been split out into a single source file. If we take a look at that, this is code that we looked at before, where we have our RESTbed logger, and only RESTbed oriented networking code appears in this file now. So this delete comic function here is got a session pointer. Make this font a little bigger. Oh, didn't take. Let's try it again. There. So we have a session pointer that's from the RESTbed framework. This comic-db is pure business logic. It has no knowledge of any kind of networking or anything at all. It just knows about how to manipulate the comic database. So this function call here is manipulating the comic database. It's a kind of a procedural API more than object-oriented, but it's not really relevant. And all these methods in here, these functions rather, are performing the corresponding operation on the database as a result of an HTTP request. So this is the RESTbed server. It's doing HTTP requests. The RESTbed service, it depends on the comics database library that I've created, this library, but it doesn't depend on any Protobuf, so any Cap'n Proto stuff. To make it easier to share the code between the client and the server for the Cap'n Proto oriented service, I've pulled out a little comics Cap'n P library that contains generated sources that we get from processing the IDL that we feed into Cap'n Proto to describe our structures and our messages or our method calls on interfaces. So there's some generated code. This is the IDL file. We've got generated sources and generated headers. That goes into a comics Cap'n P library. And that library has an include directory dependency on the current binary directory because that's where the generated files go. So any clients of this library need to make sure that they're searching the current binary dir for those included headers, those generated headers. And the Cap'n Proto library that I've written that's specific to my little generated code here for the comics database, it depends on the underlying libraries from Cap'n Proto. So there's this little KJ utility library, there's the core Cap'n P library, Cap'n PC, I'm not sure what is in that versus what's in Cap'n P. And this KJ TLS, this is for, it's either thread, I think that's thread local storage, and then this is the remote procedure call part of Cap'n Proto. Because remember, you can use Cap'n Proto just for serialization and deserialization For instance, in that address book sample that they have, that's just doing serialization to a file and deserialization from a file. So you could use Cap'n Proto purely for creating file-based archives or backups, and maybe what you're doing is transporting data between systems by exporting your entire contents to a file, taking that file physically to another system or across the network, and then importing that set of archived contents into the other system. So you could do things like that. You don't have to use remote procedure call with Cap'n Proto. You can use it just for serialization and deserialization. In our case, we're going to set up a network server. So we've got a service, and that links against our little common comics Cap'n Proto stuff, and we've got a client. So let's bring this over so you can see it. In my solution here, I've got my little comics DB. This is all my business logic stuff. This hasn't really changed since we last talked about it when we discussed boost serialization. So in that talk, we discussed how we had two different versions of this underlying comic data structure. So we had version 1, and version 1 stored the credits for a comic as strings in this comic structure. And in version 2, we encapsulate that into a person structure so that we could have more efficient in-memory storage, because many times the same script credit is reused across many issues of many comics or pencils or inks or so on. The credits, it's the same people making many issues of a comic book as it is published. So it's inefficient to keep storing their names over and over and over again as discrete chunks of memory inside RAM. So we're going to use person pointer in version 2 to share that those credit names between different issues of the comic. So we had version 1 and version 2. In this example with Cap'n Proto, I'm just going to use version 2, but you'll see how my IDL is going to reflect this person, this comic, and then the operations that you can perform on the database. These I didn't do load because load is not relevant to network procedure call. But we can read a comic out of the database by ID. We can delete a comic by ID. We can update a comic by ID, supplying the new data. And we can create a comic supplying data, and we get back the ID of the newly created comic. So what we've got here is our business logic, and how we want to represent that in the IDL of Cap'n Proto looks like this. So I don't have any syntax highlighting on because my IDE doesn't know anything about Cap'n Proto syntax. The full syntax is described over here on their web page in the schema language page. So we'll take a look at that before we go. We'll take a look at the documentation before we go look at mine, since he's got syntax highlighting. So every file has to have a unique ID, and you can generate that by running this little tool and giving it the ID command. It'll just spit this text out to standard output, and then you can capture that, copy paste it into the file. And Cap'n Proto understands some primitive types like text, date, 16-bit integers, unsigned integers of specific sizes, and so on. Sorry, date is not a built-in type. That's the user type defined down here. So to define your own types, you use struct. And every struct consists of one or more fields, and the fields are numbered. And the number associated with the field, they start at 0 and increment. Now, as your data structures evolve, and we discussed this in boost serialization, how to migrate a version 1 comic into a version 2 comic, in Cap'n Proto, what happens is that the numbering on the fields, which again begins at 0 and goes consecutively higher. Now, you don't have to list the fields in numeric ID order. You can list the fields in whatever order makes sense for you as a designer of the data structure. But the numbers having no gaps and increasing consecutively give Cap'n Proto infrastructure the capability to identify, oh, you're reading an older version of this structure that's missing the newer fields. I will set those newer fields to whatever their default value is. And that's how it can help you excuse me. That's how it can help you migrate between versions of your data structures. So you can also have, as you see here, you can have a struct within a struct, and you can have enums. And here we referenced a structure that was defined later. That was perfectly okay. We didn't need to forward declare it. Note that while fields are terminated with a semicolon, structs are not. So a struct definition is just terminated by its closing brace. You'll also notice that the types come after the names. That's their design choice for this interface description language. They believe that the types following the names is more readable. It's a judgment call, but they prefer to have the field names appear first so that you can scan the field names, because that's kind of, in their mind, that's what you're usually interested in. There is a built-in list type. It's parameterized by another data type, so that can be a primitive data type, like it can be a list of uint 16s, or it can be a list of your own data type, as is done here. So a person is associated with 0 or more phone numbers. A list can be empty. They use pound signs for comments, and they have a recommended usage for placement of comments according to their idea of what they consider to be readable. And for built-in types, they have void. Void can be useful to, it's not often used, but it can be used to specify the presence of something for discriminating purposes. For instance, to say that it's a certain type within a union, a discriminated union, you can specify that, well, this flavor of the union is distinct from the other flavors, but there's no data associated with it. We'll see an example of that a little bit later in their documentation here. You have bools. You have integers of 8, 16, 32, and 64-bit sizes, and their corresponding unsigned integers. And you have floats and doubles, 32-bit and 64-bit floats. You also have arbitrary length text fields and data fields. The text is always UTF-8 encoded, and if it's of type text, it will always be valid UTF-8. If it's of type data, that's essentially a list of uint8s, and it's a list of bytes. It's uninterpreted. It has a size and a payload, and that's all you know about it. And then you can have lists of any of these things, including your own types. A struct is just a set of named typed fields, and they're numbered consecutively starting from 0. Fields can have a default value. Again, I mentioned that when you add new fields and you read an older version of the struct that doesn't have those new fields, the fields are assigned default values. So this is how you would specify what is to be used on a field that you've added in a new version of your structure when you're migrating old data, what default value it should get. You can also have a union, and unions are associated with a name, and the individual fields within that union essentially act as if they are fields within the enclosing struct. So a union can only appear inside a struct. It can't appear at the top level. It has to appear inside something else. And that's a little bit different from a C++ union, but the details in here. He explains the rationale why. You can read that if you want to know the details. He's got that's rationales explained here. Why aren't unions first-class types? He also has groups, and I didn't find groups to be a particularly compelling use case in their little example here. It's more of a compelling use case when you've got the case of unions. So you can think of a union of groups as essentially like a union of structs, right? So there's not a, again, these fields appear as if they are inside the enclosing struct because they're inside a union, even though they're inside a group. This does not, it's not strictly a union of structs, which you could have, but if it was a union of structs, then each struct would have its own field numbering within the struct definition that is inside the union, whereas in this case, the fields are numbered consecutively inside the enclosing struct. That's a little bit confusing possibly, but it makes more sense when you read through the details of this documentation here. We're just skimming it over. There's also possibility to have dynamically typed fields and enums. As I mentioned, each enum has a value, and those values must have, again, consecutively increasing IDs starting with 0. And in a language like C or C++, where enums represent, integer values, you can get those numeric values associated with the enum directly. Now, for the remote procedure call part of the interface description language here, you basically declare interfaces with methods. The methods have IDs that, again, begin at 0 and are added increasing ID number with no gaps. And the form is a list of arguments surrounded by parentheses. In this case, there's no arguments, so it's just open, close, paren. And then that kind of C++ 11, 11 function call return value type syntax with a list of results returned by the method. Now, this implies that a method can return multiple values. It's not required to return a struct that contains multiple values because it's a list of return values. And you have the capability of having a hierarchy of interfaces. So here you see an interface directory extends the interface for node, adds more stuff. Notice that the IDs for directory still begin at 0 even though it extends a node. So node, the IDs for the methods inside the node interface begin at 0, and they also begin at 0 for any derived interface. You can also, as shown here, you can have default values for parameters to a method on an interface. I didn't get that fancy with mine. There's also the possibility of specifying generic types so that you can eliminate common boilerplate in your interfaces. They're similar to Java generics and to C++ templates, but when you run the little code compiler, they don't actually expand to C++ templates. They expand to the equivalent of what you would see for the generics having been substituted with all the specific types that are used in the IDL. So rather than emit a generic templated-based representation of these generic types in the IDL, as the IDL is processed, they know exactly which actual types are substituted for the type parameters, so the generated code only contains the interfaces for the types that are actually used. There's generic methods as well as generic interfaces. You can define constants, and there's a way to specify scoping and aliases. There's a way to put common definitions in a file and then import that file. You can import all the definitions, or you can import them with an alias, or you can import just specific definitions from the file. There's also a way to associate arbitrary annotations with pieces of your interface description language, and you can use that to associate extra metadata with the interfaces. The metadata is not communicated across the network, but is queryable and from code, so that you can use that to drive your implementation, where you've got common areas between interfaces, but you need to distinguish between those interfaces for the purposes of where they are different. So you can drive things with some metadata that way. Maybe supply, boilerplate strings or what have you. It's anything you want. Any data type that can be represented in the IDL can be associated with metadata. You can associate metadata with the whole file. You can associate it with an interface. Or you can associate it with particular fields. You can associate it with particular methods. It's pretty free form where you can put the interfaces. Now, a Cap'n Proto file does require a unique ID for the file, but you can also supply explicit unique IDs for your data types and your interfaces that you are writing. Now, under the covers, if you don't supply an explicit ID, Cap'n Proto will generate one, and the algorithm by which it is generated is described in the documentation here. But for the purposes of versioning, you may want to generate an explicit ID so that you can track which specific one is being used in the communication or used in serialization. There's a section here on advice for evolving your protocol, which is almost certainly going to do. And that pretty much covers the basics of the IDL. So now, with that in hand, let's go back and look at our IDL that we've created for our version 2 comics database here. So we can see that we've got our ID for the file that is required for every file. I've got my person struct. I've followed their kind of documentation style where they say, I think specifically speaking, I should have a blank line there, but they basically say put the comment for the thing after the declaration of the thing. So in this case, it's a comment for this struct. Down here, this is a comment for that field. I could have put the comments side by side with the field as I've done down here for the interface. So I've got a person struct that has a name field. This is my first field, so it begins with ID 0. And it is arbitrary text, so I'm using the built-in text data type. They, in their documentation, wrote the declarations like this. They wrote it like colon text all smushed together. I kind of like a little bit of extra white space in there. The colon here is a separating token between the field definition and its data type. It's not part of the name of the data type. So you can do it either way, any way you want it. And similar, I've got my comic structure that has the title of the comic, the issue number. I chose int 16, and notice that for integer types here, you've basically just got a choice of 4 sizes and signed or unsigned. That's it. So if you need bigger than 64-bit integers, you're going to have to encode that as a string, your own big num string. And if you've got 24-bit integers, which is common in graphics code like 8 bits of red, green, and blue, you have to expand that to the next available size, 32 bits. Or use some alternate representation. However, if I use the built-in int representation, that's a binary representation of an int. Whereas if I have to go with big nums or list of uint 8 from my own binary representation, I've got extra work to do to make sure that if the big nums are communicated as text, that the text represents valid big nums, I have to do my additional validation now, and it's transmitted as text as opposed to being transmitted as a binary, so it's not as efficient. There are big gnome representations that just specify things as a stack of 32-bit or 64-bit words. I could have a list of uint 16s or uint 32s or uint 64s to represent those words. But again, it's up to me to validate that those blobs of data actually represent valid values. I get no help from Protobuf once I go out of its built-in data types. All my remaining fields are all credit fields, and they're all persons. So they're all instances of the person struct. And we'll see how that translates in my client and server code when we take a look at that. And I've got a database interface. We've got the create, read, update, and delete methods that we're used to. These are the ones that we've implemented in our REST API server. This one here, this list method, this is a new method that I've added in the Cap'n Proto example, and it just returns a list of all the known IDs in the database. So the method is called list. Its field ID or method ID is 0. It takes no arguments. It returns, let's go over here. It returns a list of int64s. I've arbitrarily chosen int64 as the data type for my IDs. And the name of that return value in the return in the list of return values, the name of that specific value is just called list. So it's might be a little bit confusing at first. Here's list, and then here's list again, and then here's list a third time. This is the first one is the name of the method. The second one is the name of this field in the return values. And the third one is capital L list is the data type specifying a list of int64s. Now, in CMake, let's go up here, take a look at what I've done for VC package. So this is basically the VC package manifest file that I used for the REST bed example. I've just added Cap'n Proto on here. That's the only thing that I did. And when you run your CMake configure stage for the first time, configured with the VC package toolchain, it will go and download all those dependencies and build them. And having done that, let's go over here. So as is standard for the way VC package operates, in my build folder where I did that configure in the VC package installed, we got our target that we're packaging or that we're building for, which is x64 Windows in my case. And then down here in the tools folder, you'll notice there's a Cap'n Proto folder. That's where this little Cap'n P tool that they discuss in their documentation lives. And they've generated a Cap'n Proto directory under the share folder. That's where the generated package config definition for the installed Cap'n Proto in my build folder was generated by VC package. And you'll notice in here as well, there's some extra little files, Cap'n Proto macros and Cap'n Proto targets. If we take a look at Cap'n Proto macros, you'll see that in here is the definition of this function, Cap'n P generate CPP. And you give it the name of a variable that will contain the generated sources and the name of a variable that will be set to the list of generated header files. And the if I think I read that correctly, this sources could be. Oh yeah, okay. So let's just take a look at this so we're not saying something wrong. Okay, yes. The first two arguments are the names of the variables that will contain the generated sources and headers, and then all the remaining arguments are the names of the Cap'n P files to be processed. So that's where this little Cap'n P generate CPP function in CMake, that's where it came from. It came from this file. You can scan through this file if you want to see exactly what it's doing. It's basically invoking the Cap'n P tool, and the part that was generated by when the Cap'n Proto source was downloaded, configured, and built by VC Package, it was the Cap'n Proto was configured so that the location of the tool was specified in this tool's Cap'n Proto folder. So that's how it knows to get how to find this particular tool. There's also in the include directory Cap'n P folder, there's a bunch of header files. We will be using some of those in our example. I didn't explore the details of all of these, but they basically correspond to the various features of Cap'n Proto that it offers, along with some of the little helper code from that KJ utility library. The KJ folder here is where all that KJ helper stuff lives. It's not in the Cap'n P folder. So, and in the lib folder is where the static libraries live for the various targets that are imported when Cap'n P is configured through CMake. Now, you'll notice here that this pile of libraries that's on the link line here, I literally just copied that out of the documentation where they're explaining how to get set up with CMake. The only one that I added on here manually was the RPC one at the end, because when I did my first experiment linking against the code after I'd added interface definitions to my Cap'n P file, now I need the RPC support library code, and I was getting a missing symbol, so I added Cap'n P RPC onto the end, and then that satisfied that link error. So again, little bit of trial and error and figuring things out by just, being reasonable about what's what. You go over here and look in the directory, and there's the Cap'n P RPC.lib. That seems to be the one you would need to link against if you need the RPC support. So now, that's all the CMake business. The rest of the changes here were just related to separating out the REST bed service from my business logic and separating out the remaining business logic from anything that I was doing any kind of network traffic. So if we look over here at the client, let's take a look at the client first. This part here, so this easy RPC client, this is discussed in their documentation as the quickest way to get yourself running with a client, a network client. And it takes a host name, port number, kind of standard connection information. I'm just using localhost because I'm just running things on my machine, and I used 8192 just as an arbitrary port number. In Unix land, you always want to choose a port number greater than 1024 because everything from 0 to 123 is reserved and you can only listen on those ports if you are running your server as root, which you don't want to do. So that's why I chose 8192. It's way up there, and it's not, it's just literally a decimal form of 8K. Just a big number to be in a safe zone, not conflicting with anybody else. If you were going to deploy any kind of service on the internet, you would probably go through an internet registrar to register your port number so that it's not going to get used by other services. That doesn't mean it won't be used by other services on other hosts, but if you're going to provide a general service like SMTP, Simple Mail Transfer Protocol. That's on an assigned port. Port 80, reserved for HTTP. Now, any machine can set up any arbitrary server on port 80, but if people point a web browser at it, they expect a machine, if it's answering on port 80, to be answering HTTP with not HTTPS, but HTTP on port 80. I can't remember the port for HTTPS, but there's a distinct port for HTTPS. At any rate, that's what I've chosen. And because everything is asynchronous with network traffic, in Cap'n Proto, everything is done by returning promises. Now my code, I've written it in a rather stupid way, in the sense that I'm making a request and then immediately waiting on the result, which is not the most efficient way to do a chain of requests, but it's the simplest way to show the library. And in Cap'n Proto, you need a wait scope when you wait on something. So that's what this wait scope is here. It's specific to this client. It's not specific to a particular interface. It is specific to this client, however. So I just stuck that in a global variable. I typed it auto. If you want to see, we can look at it. What its actual type is. It's just from that utility library, KJ wait scope. Nothing too exciting. In their sample code, these big, long, noisy types, they just wrote auto. I expanded the types from auto to explicit types so you could see what was actually going on with the library. So from our RPC client, we're going to call this getMain to get the main interface that we're going to use. Now this database method, so this easy RPC client pulled in the necessary stuff for wait scope. That both came out of this capnp easy-rpc.h header file. And just to show you what I was saying about Doxygen comments, if we just drill in there, there are some comments describing some things in here, but not necessarily every place you look has comments. This file is particularly well commented, but if we drill into, say, KJ string pointers probably also documented. It's got a little documentation paragraph at the top, but as we get into these methods, there's it's expected that the source code is the documentation because it's all inline implementation. There's not much commenting for the individual methods. It's not exhaustively documented, which personally I'm okay with. This doesn't bother me, but other people have different subjective evaluations of an API based on how much is documented. Now, that's where we're getting things like, ultimately, things like capnp request. And we can drill into it. It's coming from capability.h. In their terminology, they refer to interfaces as capabilities. And I didn't quite understand how you would implement this, but there's some discussion in there about how the way you secure a set of services is to make sure that you never return an interface to somebody that's not supposed to have that capability. So that's why they use the terminology capability associated with interfaces. An interface, if you have an interface pointer, you have the capability to perform the operations listed in that interface. I didn't quite drill all the way down into this to see how you do some kind of authentication scheme to authenticate a client and then only allow them the interfaces that are allowed by their authenticated identity. The whole issue of authenticating and authorizing network clients is a whole topic in and of itself, but there is some discussion in that in the documentation. And if you're not doing your own private service on your own private network, you should definitely look into some kind of authentication and authorization so that you don't have people discovering your service by scanning every port on your internet-facing machine and then start manipulating your interfaces. It's not like Cap'n Proto is some kind of super secret sauce that nobody's going to recognize. They're going to be able to recognize it. So if you want it secured, that's up to you. I believe Cap'n Proto provides some mechanisms, but nothing as full-featured as this easy RPC client to get you going out of the box. So we're calling getMain on the client, the easy RPC client that we created, and the template we're passing in is this database. The database is coming from the generated comic.capnp.h. This file is in my build folder. The font's a little small, but trust me, it's in my build folder. If we look in here, here's all the other CMake generated stuff, the project files and all that. There's the C++ source file that it generated, and here's the header file that it generated that we're looking at. So inside here, there's this database class, a bunch of forward declarations for some structs, and these structs represent the packaging of the parameters and the results for every method call in my little IDL. So if we go back to our little IDL here and refresh ourselves, we had a list method, a create method, a read method, an update method, and a delete method. So we have list params and results, read params and results, create, update, delete. And it was smart enough to recognize that because delete is a reserved keyword in C++, that in the places where it used lowercase d delete, it appended an underscore, so it was lowercase delete underscore to make it not a reserved word. So that was a nice touch. There's a bunch of generated stuff in here. This stuff is not commented at all because it's just generated by that Cap'n P tool as part of our build. Tracing through this, I mean, it's not particularly complicated, but it's noisy, and unless you are fully versed in what's really going on here, it can be a little confusing, but fortunately we don't need to look at that much. We just need to know that this database represents the main interface that we're going to use to talk to our server. And because we're acting as a client, we're using this nested client class from the database, which derives from an arbitrary, sorry, not an arbitrary, but an abstract Cap'n Proto capability client class. And inside our database client, you see inside here are methods called list request, read request, create, update, delete. Let's get rid of these. And so that gives us our representation of the client interface. Next, we need to make a request. And through this parameterized request template class, it's parameterized off of the params that go into the request and the type of the params that come out of the request. And I just expanded this data type here to be making it more explicit about how we are interacting with the library. But I think ordinarily in, client code, you probably write it like, you probably use auto because you didn't necessarily need to see those data types. I mean, it can deduce all that from the return type of this method. So we didn't need to be explicit about it, but I just wanted to be explicit about it to show you what was going on. So this is an object representing the request we're going to make. And we get a response. Now, this request, we obtained it from our database client interface. So now we have a request object. In this case, there's no arguments, so we didn't need to build the parameter list. We'll see in just a second what that looks like to build a parameter list to a method that does take parameters. And then we get a response by telling that request to be sent. And when we call send, what we get back is a promise. So in our case, we want the results right away. So after we send it, we have a promise. Then we wait on the promise until the request is fulfilled and it has value, has the return values in it. And from the response, we call getList. Now, maybe it was not the greatest idea for me to call the return value list here, due to the unfortunate fact that their aggregate vector style type is called list. But I called it little l list, so it capitalized the first letter of the name of that field and gave us a getter in the generated code. So if we drill into this, again, this is all generated code. This is the comic.capnp.h generated file, which we had generated by calling that CMake function to run the CapnP tool on our IDL to get and tell it to compile for C++ to get this generated file. So if the list of stuff that came back, if we drill in, so this getList returns a CapnP list with some template parameters. If we drill into the CapnP list type, we see that, okay, there's an embedded reader, there's an embedded builder, and the reader, that's what I'm using, right? Oh, it's templatized. So this getList returned a database list results reader. So it didn't return a CapnP list. It returned the nested reader type from CapnP list with the template arguments supplied. So when we called getList on the response object, we got a reader for a list. This is a generic reader for, anything of type T, and that reader has a size operator, and it has an array access operator where it basically does an assertion to make sure that we're not trying to read things out of range. I'm going to bet that compiles away in a release build, so remember to test debug builds to make sure that you've got the assertions happening. So I checked the size, and if any IDs came back, I guess I didn't really need to do it since the only thing I'm doing is a for each on the list here. The corresponding reader has begin and end methods, so we can use it in a for each loop. And this type here is just a long, it's a int64t, essentially. So I'm going to print out the ID, and then for every ID, I'm going to issue a read request. So this is creating a different request from the one we had before. This was a list request. This is now a read request. It's got a different type. Again, I've specified the type out explicitly so you can see what's going on. And then I'm setting I'm calling set ID on the read request. Why is it called set ID? It's called set ID because the read method has an input parameter called ID. So on the request, I get setter methods that correspond to all the input parameters of the request. On a response object, I get getter methods that correspond to all the fields that are listed in the response of the interface method. So I create a request, set the input parameters, send the request out on the wire, and again I'm doing simplistic synchronous code here, so I just wait on the request to get the answer immediately. And then I've on the response, again, I've got getter methods for the fields listed in the response. What was the field listed in the response? It was named comic, and it returns an object of type comic. So this is my struct that I've defined up here, which holds persons, which is the struct that I defined even higher. So back here in my client code, I am getting the individual fields out, and if it's a field of type text, I can call cstir to get the char star style pointer for that. And remember, this is UTF-8 encoded text. So if I, for instance, needed to do some kind of operation where I'm walking across characters in that string, I need to remember that they are UTF-8 characters, and there's not necessarily a one-to-one mapping between bytes and characters, because UTF-8 is a multi-byte encoding of all non-ASCII characters in Unicode. So, something to always think about. In my case, I just know my database has ASCII, so cstir is perfectly fine. And this would also be perfectly fine if I'm operating in an environment where my standard out is perfectly happy accepting UTF-8 strings for the purposes of display, which I believe is the case for the standard Linux console. Not 100% certain about that, but I believe that's the case. So I'm printing out my text fields, and for the credits, getting the credits field, for instance, the script credit, that returns a so on the comic reader, the getScriptAccessor returns a person reader. And then the person reader has generated methods to return the name. Now, maybe when the thing was encoded, it was encoded from an older version of my structure, and my older version of my structure didn't have a particular field, so I may have to check when migrating old versions that the fields that are present in the new version, whether they are present in the version I'm reading, the version that I am deserializing. So all these fields in the generated code, they all have a has method in addition to the getter. My code, I took the easy route and just assumed that everything's present. So I call the getter without checking the has. So I am printing out those credits for every ID that was returned back in the list of IDs from the server. So that's what the client side looks like. If we go look at what the service looks like, let's go over here to Cap'n P service. Again, now the service needs to have access to my business logic. It's possible the client may have some business logic headers that it's including, but it's not going to have the database headers. It might want to convert the wire format of these structures to the business logic form of the structures, and it might want to include comic.h, but the comicsdb.h is included only by the server. It's not needed by the client. The client does not directly interact with the database. It interacts with the network service that is owning the database. The network server has the database in memory, in my example. So I need to include the header for my business logic. I've got the header for the generated code that came from the Cap'n P tool. I've got that same easy RPC, except this time I'll be using the server side of things, not the client side of things. And to implement a server, let's go down and look at that. You need to instantiate the easy RPC server with an instance of your class that implements the methods described in the IDL for the interface that the server is providing. So in my case, the interface was called database, and kind of following the example that they were using, I've called my server implementation database impl. And it has to take a looks like I got a redundant set of parentheses here, but take those out. this server class, this easy RPC server, if we drill into its implementation here, or its declarations rather, you'll see that the constructors, which one am I using? This KJ heap thing returns an own T. So this easy RPC server, I think this is just a way of specifying transfer of ownership. Oh, it says you can implicitly convert an own to a capability client. Okay, that's what's happening. So we're ending up in the, if we look at this, there's the constructors that take the capability client as the main interface, and then there's, network binding information, which is what we're doing. This is our implementation of our interface, and in this this KJ heap thing, it forwards any arguments you give it to the constructor of the template argument class. So in my case, my database impl takes a reference to my comic database, and my I introduced a little namespace alias here so we could be more clear. Let's use that. Okay, so my comic database I call load to get it loaded into memory. That just loads some fixed data from some little example code that I have. And I'm going to make my database impl referencing that comic DB. I'm going to listen on localhost and port 8192. It's symmetrical with the client. Obviously, it has to be that way. And again, I need this wait scope. Except this time, what we're going to do is we basically want to go into an endless loop answering connection requests. And when those connection requests come in, we will establish a connection and then answer method calls on the connection that's been established and return results. And as long as they have the connection open, we will keep listening for messages and keep responding. And then when they close the connection, we will close the connection on the server side and go back to waiting for more connections. And again, this is network I/O, so everything is going to be asynchronous. So we need a wait scope for that. This never done thing is just essentially a it's essentially just a global. I think it's declared as a static inside this underscore class. What is this underscore thing? It's a thing they use everywhere. But it's just a simple way for them to provide you with a singleton that you can use to express your intent that we're going to go into this infinite loop, which is never done, and we're sitting here waiting forever. So that's how we set up the server. What does it look like when we implement this interface? So we've got our implementation class, and it implements the server interface in the generated code. So the server interface for the server specification, it's the interface kind of overloaded here. In our Cap'n Proto file, we had an interface called database, and this is the stuff we want to implement on the server. The generated code created a nested server class, and that nested server class has the corresponding types for the input parameter list and the output result list for every method. There's also a new call context type that basically holds the inputs and the outputs for either call. and there is the method that implements there is a C++ method that implements the corresponding Cap'n IDL method, and they all return promise void. So they're asynchronous, they return promises, but you might have expected that the results would be that the return type of the C++ implementation would be a promise of the result type, but it is not. The result type is found inside this context type that is created for each of the methods that we've declared on an interface. So that's just a little bit unusual. I'm not sure of the design rationale why they did that, but like these guys, this is their second turn around on doing one of these kinds of things, so I'm sure they had a good reason for that. So that is why our implementation of the server portion of this database interface, this is our own junk. This is our business logic stuff. We're just storing a reference to our comics database. I mean, that means in my code, the lifetime of this thing, this comic DB, is bound to the lifetime of this server. If we get rid of this database before we get rid of the server, then we're accessing, dead memory. So you don't want to do that. That's just the way I've chosen to do it here. You can do it any way you like. It's just normal lifetime stuff you have to be aware of. And we are overriding list, read, create, update, and delete. Now here is where I mentioned the name of the method in my IDL is called delete. Now, delete is not a reserved word in Cap'n IDL, but it is a reserved word in C++. So in C++, the method is called delete underscore. And these are all overrides of the base implementation. If we go back and look at this generated code, you'll see down here that the method is indeed called delete underscore. It's not called delete because delete's a reserved word. So that's nice that it understands reserved words in the target language in the code generator, and it's not going to generate C++ code that doesn't compile, forcing you to go back and edit your IDL and choose a name that isn't convenient or meaningful to you simply because it happens to match a C++ keyword. So that's a nice touch. So I'm going to override these methods. And in this example here, I've only implemented list and read. When I used my little resharper for C++ tool to generate the overrides, it generated the override by writing code that just delegated to the base. And if we drill into the code of the base, which is generated code, it just calls a function called internal unimplemented. So you always have an implementation when you derive from this generated code and override methods. So you can be confident that, first of all, there's no abstract methods in this generated code. You could instantiate this purely without deriving from it. What you would get is an implementation that answers all the methods and returns a response that says it's not implemented. What happens on the client is that results in a debug build, it results in assert. I think in a release build, it results in a call to terminate. The client just dies if it tries to call a method that's not implemented. But it does mean that everything builds, and there's no, you don't have to go and generate annoying boilerplate code for these methods because they were only abstract and didn't have any base implementation. So for me, I just needed to implement my business logic and deal with it that way. Now, I did find this a little annoying in that it could just be because of the way I've implemented this as a vector of comic structures. You may remember from our previous presentations when doing a REST API to this that one of the REST operations we allowed was a delete. And to implement delete, what we did was throw a magic sentinel into the issue number for the comic that was deleted. So that's why I've got this check here, comparing the issue number to this magic sentinel. Now, why did we do that? We did that because we are using indices into a vector as our IDs. Now, in a real, relational database, the IDs, they can be non-sequential or whatever. You can have the IDs be arbitrary, and you don't, deleting a record from a relational database doesn't change the IDs of any of the other records in that same table. However, if I had called stood erase on the deleted comic, that would change all the indices of all the other comics that were in the vector by removing that hole. So I have to keep the hole. So when I'm reporting a list of valid IDs in this list interface method, I have to scan through them and check to see which ones are actually there, which ones are actually valid. I can't just return 0 through this, the size of the vector -1, because not all of those IDs will necessarily be valid comics. So I had to do a copy here by walking over the IDs from 0 to size -1, checking each issue to see if it was a deleted issue, and if it wasn't, then I can push that ID onto this list of IDs, vector of IDs. Then I get a builder for the results. So this get results is, as I mentioned, this list context is a context type for every one of the methods on your interface. And each context has basically two things in it. It has a getter to get the params, and that gives you a params reader, so the corresponding reader for the params type, and it has a builder that it returns for the corresponding results type. So in my server code, I've built this vector of the valid IDs. Then I have to get a builder for the results of this method. The results of this method contain a field called list. If we go back to our interface definition, we'll see here the name of the field in the list of return values is called list. So that's where this set list comes from. And the type of the argument to this thing, it either has to be, there's several overloads here for the setter. It either has to be a reader on another Cap'n Proto list of type int64t. So 64-bit ints. I can set the list from a reader on another list, but I don't have a Cap'n Proto list, and I can't, it turns out you can't actually construct one directly. You have to use these readers and writers. So if we go and look at Cap'n Proto list, you'll see here the default constructor for this list type is deleted. So you can't create an empty one. There's an underlying reader, a builder, and then everything else is private. So the only thing you can do here directly from the list is use the list builder, and if we look at the constructors for the nested builder type, we can build a builder from another list builder. We can build an empty builder by saying a builder of null pointer, or we can construct a default one, but it ends up being empty. And when you try to call set, it gives you an exception because it doesn't have that many elements. So, round and round and round we go. This is an example of where I was saying it can be a little bit confusing to try to figure out how to use this stuff when you don't have a complete set of reference documentation or an example that shows how to do this. If we try to consult that calculator sample, the calculator sample doesn't do any of this. It doesn't build any lists in the return results. So there's no example to see how to do that. What I eventually figured out was that there was this thing called an array pointer that takes a pointer and a size. It's basically a span. And there's an overload of set list that takes array pointer, and I could use that to set the list result field. I could use that to set the list field on the result. That's the more correct way to say it. And once you've implemented one of these methods, remember the promise is not on the type of the return value because that's all shoved into this context. It's always a promise of void, so you return KJ ready now to indicate that now that I've stuffed the data into the results field of the context, the promise has now been fulfilled on the server side, and the rest of the infrastructure in Cap'n Proto communicates that all the way out. Now, in this case, my little database business logic here wasn't doing anything complicated. There's no possibility of exceptions being thrown. I didn't need to worry about any of that. It's different for the read method. For the read method, I mean, we get this ID out of this request from the params getter on the context object. And remember, every method call has its own distinct context type. So this get params has methods that are different than the get params up here. In fact, if we said context.get, does it even have params? It has params, but there's no getters on that because it's a different type. Whereas down here in context get params, we can see that it's got those same things that the other one had, the boilerplate 2-string total size, but it also has this get ID method that the other one didn't have because the other method didn't have any parameters, whereas this method has a parameter called ID. That's an int64t. But this ID, we haven't validated that it's one of these valid IDs we returned from the list method. It's just an arbitrary integer that came in. The business logic validates it. And if it's not a valid ID, the business logic throws a C++ exception. The business logic has no concept of being called in response to a network request, whether it's an HTTP REST API request or whether it's a Cap'n Proto custom remote procedure call request. It doesn't know anything about that. It just says, hey, you gave me a bad idea. I'm going to throw an exception and let you figure it out. So the business logic for this server method is encapsulated in a try catch. And it wasn't obvious to me what to do in the catch case, how to return indication of an error. But as I mentioned before, on the client side, we didn't validate that the fields were present before we tried to obtain their values. But there is those generated has methods that you can use to check to see if it has those values. So everything should have an issue number and a title. We could have used that to check to see whether or not the requested value that we got back for an ID was valid. Why would it be invalid, you say? Because right up here we already went through and validated all the IDs that we returned to the client, so they should all be validated, correct? Well, this is a remote database, that can have multiple clients, not just a single client. So you can't assume that just because the ID was valid when we asked for a list of valid IDs, that it is still valid when we attempt to read the record associated with that ID. It could have been invalidated by somebody else deleting it between the time we got the list of IDs and between the time that we asked to read the record associated with an ID. So the upshot of that is, while we're in this server, this read comic method could throw an exception, in which case, if it did, we would not assign anything into the results, and we would fulfill the promise of void. That's the return type for this method, but none of these setters would have been called. And similarly to what we did when we are setting parameters, we're going to get a builder for the results, and then we get a builder for the comic field in the results, and then we start calling setters on the field in the comic. The title and issue are directly settable without having to go through something else, but all the credit fields return objects. Their getters return objects, which we then in turn call the setters for the field within that object. The person object only has one field, this name, and you can see there's a parallel here between we scrape it out of the name field out of the person object associated with the business logic code, and we shove that into the name field of the person object associated with the networking code. Now, you might ask yourself, is it really good to have a network agnostic representation of the data with a parallel set of structures and this network representation, this Cap'n Proto description from the IDL of the same structures, and I have to keep synchronizing them as I change them? And the answer is, it depends. You may decide that the primary use case of your data structures is for the purposes of network communication, in which case the generated classes from Cap'n Proto can serve as the containers for your business logic. What might such a use case be? Well, suppose the only reason you have this Cap'n Proto based server is because you are gathering telemetry. The data structures representing the telemetry are specific to the network communication. Those data structures only exist for the purpose of sending messages to some server to report telemetry back up. The organization of the fields and how their names and how many there are and what their values are is only relevant for the purposes of sending this network message, in which case the Cap'n Proto structure is the structure for your business logic use case, because the use case is telemetry. However, particularly in a legacy system where you may be, even if it's still a telemetry use case, you may be wanting to send objects back up that, in the Cap'n Proto description, that are one-to-one with your business logic objects, and you're not going to go and modify all your business logic to start using Cap'n Proto. That would be a prohibitively expensive change. So you're going to have some marshalling back and forth between business objects and these network message objects. And that's just what I'm doing here at this code we're looking at. I am marshalling the code, marshalling the data out of a business logic representation and into this network representation. We did the same thing when we were doing a REST API with these other frameworks, because we marshaled the business logic representation into and out of JSON, so a text encoding. In Cap'n Proto, we at least get the benefit that the encoding will be more efficient for numeric types, and there's also, we can bolt on compressors to use LZW or zlib compression on top of the Cap'n Proto encoding, which is already efficient, but if we have a lot of repeated text, or large text fields, which will compress better with some kind of, dictionary-based tokenizing compressing scheme, we can get the benefit of that. Now you can also, with a REST API, because the JSON encoding includes a lot of text is obviously a complete text representation of everything, because that's the nature of JSON. You can use Gzip compression on top of your content transfer encoding for JSON to get compression of large responses or large requests. We have the same option in Cap'n Proto. There's some discussion of it in the documentation. I didn't investigate how to bolt that on, but it's a common use case, and even large binary blobs often have repeated byte sequences that can be compressed. So that's available as an option. But there's still likely to be some marshalling into and out of business data structures as you create these network messages or respond to network requests. The other methods I didn't implement, but they're not substantially any different than what we've done here. The fundamental thing to understand is that this context object, or this context type rather, that's created for every method in the server has a params portion to it that represents the input parameters to the method. It has a results builder that you use to get at the results that you're going to build in terms of the output of the method calls. So for the params you get readers, and for the results you get builders. You call the corresponding methods to get everything out or in, depending on whether you're reading params or setting results. And let's look at a demonstration of this running so you believe me that it actually works. What I have done is I've put the Cap'n P tool in my path just so you can see what it looks like if we just run it with help. It's got, as was mentioned, every IDL file has to have a unique ID. You can put IDs on fields and structures. Maybe not fields, definitely structures. That was in the documentation. Probably can put it on fields too, but maybe only structures. So if you need to generate an ID for your file, you can run it with ID. It'll just generate this little hex value. There's the compile operation to generate source code from interface description language. They call them schema files, but it's really an interface description language. If you've done any coding in COM or in Corba, an interface description language is something very familiar to you. They also have the ability to do convert, so that can read using the interface description language. That's a complete description of structures and messages. So if they are stored in a file, you can use convert to dump them out from the file to text or to JSON. It can do those conversions all by itself. You don't necessarily need to write your own tool just to be able to dump out the contents of a file that is saved from an IDL description. I have also put in the path in my build directory to my little client and server. This is my debug build. So if we run the server, let's set the service as the startup project, and we'll run the client. So the client's running. Run the server. I guess it wants to build some things because I was editing files as I was talking. Okay, so now the service is running. Oh, it's really annoying when it puts this over top. It's not Go away. Oh, it's because I threw an abort. Let's try this again. Let's abort that. Okay, the server's running. We'll go back here, and we'll try the client again. So now we've hit the breakpoint. It's doing the list. If I put a breakpoint down here, so now the client has obtained the list of IDs. It's fetching the comic associated with each of the IDs. I happens to know there's 2 records in here built in by default. So it fetched the first record and fetched the second one and printed the output to the console. So that's how it all looks from the server side of things. If we flip it around, stop the server, and we set the client as the start project, and then we go over here and run the server. So now the service is running, it's bound, and we can go into the client. Nope, that's the service. We go into the client, and we can put a breakpoint here. We can run the client. It's slightly out of date. We'll run it. So now it is connected. We've got a wait scope. We've got our main interface. We've built a request for a list, and we will send the request and wait for the response. It already came back with the answer. The response had some IDs in it, and if I bring this window over, you can even see that in the debugger. So the response came back with a list results reader, and the reader has a segment. The packaging of messages is described in terms of segments. I'm not sure we're going to be able to see the raw data here because it's all encoded. In the response object, it's packed in memory according to the way Cap'n Proto, not Protobuf, Cap'n Proto, has packed the message in memory for transmission over the wire. But these getters are going to extract out the stuff that we're interested in seeing, so I can do a read request on the ID that we just read. So the first ID was 0. The 2 IDs are 0 and 1 at the moment. And now we'll send a response to do the read, which we've already gotten the answer. And now here is the result. This is again, it's a reader with segments and so on. But if we print these fields out, let me bring this window over here so you can see it. So for ID 0, here were the fields that were printed out as we got them out of these objects. So, now that you've seen it in action, let's sum things up where we are. It's well supported on different platforms, Windows and Linux. It's supported in VC package, so I can pull it down easily and consume it from CMake. I have access to that little CMake function that does the code generation, so I don't have to worry about that. This guy here. So I don't have to worry about writing my own custom bespoke CMake logic with a custom build step and all that junk in order to generate source and header files from my IDL description. That's all taken care of for me. I can easily write a network client. I can easily write a network service. And with a little bit of drilling through header files and some assistance from Stack Overflow, I can figure out how to populate the input parameters to my method calls and how to populate the response and create a custom RPC network service. Now, as I mentioned before, if you're going to be deploying this on the open net, you're going to need an authentication and authorization solution, which I didn't see a ready-made example of how to do that. So that's going to be some work figuring that out on your own. But the underlying library is stable. They're making active commits. They're actively working on it and improving it. I didn't look at the nature of the open issues but on their GitHub project, but they're relative to the number of issues that they've closed seemed reasonable. This is not advertised as, a finished, fully featured implementation. Particularly in the RPC side of things, they gave it a version number of I think 0.4 or something like that. So they're not calling it a 1.0 fully feature complete release. However, if you bolt on some authentication and authorization, which I don't think is necessarily difficult, but again, there's not an existing example of how to do that, at least in the Cap'n Proto GitHub project. So it's going to take a little bit of work, but I don't think it's, the kind of thing you're going to have to work at creating from scratch, from whole cloth. I think it's just going to be a matter of figuring out how to adjust things so that you're combining an existing authentication and authorization framework with the serialization and RPC capabilities of Cap'n Proto. And as I mentioned, the idea of an interface being a capability, it's going to look something like the only thing a non-authenticated client can do is to make a method call to authenticate itself. And if the authentication is successful, then it obtains in the result of that authentication call an interface that allows it to do something else. And this is basically you can't use a computer till you log in kind of thing. In a custom RPC framework, authentication and authorization is up to the application. It is not provided by the system. Whereas in HTTP, there is at least, basic and digest authentication and that are available to HTTP REST APIs. So there's that's part of the HTTP protocol, though. That's not part of the REST specification. That's part of HTTP itself. And of course, I've been talking over a port, and all my messages have been getting transmitted in the clear. They haven't been encrypted. So for proper authentication, you should be using TLS on top of whatever your network traffic is. And I didn't do that in my example, but if we go back here, let's Control-C the service. If you say VC package search Cap'n Proto, there is a Cap'n Proto with an open SSL feature to use transport layer security that builds libkjTLS, which is transport layer security, by linking against OpenSSL. So there's an OpenSSL version or feature for Cap'n Proto. I didn't drill into that KJTLS library to see exactly what it was doing, but transport layer security is how you invoke encryption on a network connection for your own non-standard network protocols. So it's encrypting, not authenticating, but encrypting the network traffic over a socket connection, an arbitrary socket connection. And that's essentially what you get when you use HTTPS instead of HTTP. Even when you use HTTPS to talk to a website, you must still authenticate yourself against that website in order to do privileged operations. And that is where the authorization and authentication parts of HTTP come into play. The HTTPS part just encrypts the traffic so that somebody snooping your network traffic can't see your username password transmitted in the clear, for instance, when you're logging into Gmail or whatever you're doing over HTTP. Similarly, you'd want to secure your own network traffic when using Cap'n Proto. Even if you're using Cap'n Proto on an internal network, it would be wise to use some sort of encryption and authentication authorization scheme, because the last thing you want is somebody penetrating your internet accessible portion of your network. Now they're on your internal network, and now they've got free reign to do whatever they want on your internal services without any additional checks. So even on a network service that is only accessible from inside your own network, it is still wise to use encryption, so that's transport layer security, and authentication and authorization, that is some sort of scheme by which you authenticate that the person requesting to do these things is who they say they are. Those are all aspects outside of Cap'n Proto. There's no reason for Cap'n Proto to implement those features. All they need to do is provide appropriate hooks so that those features can be supported. And as I said, the idea behind Cap'n Proto interfaces, the reason they call them capabilities, is because if you obtain an interface, that means you've been granted the capability to perform all the operations on that interface. So a typical thing would be for the very first interface that unauthenticated clients can obtain is an interface where they provide some credentials to authenticate themselves and allow them to get an interface that allows them to do something more useful. Again, the only drawback I see with this library is that it could use better documentation and it could use more examples. When I went hunting around for examples, it seemed to be that all the ones that were out there on blogs and whatnot were talking about the Python API. So that wasn't useful to me as a C++ programmer. I could try to transliterate between the API surface of what it looks like in Python versus what it looks like in C++. But in general, I find that Python and C++ are so different in terms of the way they manage memory and the way that these little blobs of bytes are copied around and stuff, that I don't find that useful. So I just stick with C++. So that is about the only shortcoming I can see on this library, that it could have better documentation and it could have more examples to show more of the features in action. Otherwise, you're drilling through header files and figuring things out, which can be done, but it's certainly easier to figure things out from an example or from documentation. But otherwise, I'd say this is a pretty good library for custom RPC. And that's the end of this presentation. Next month we'll be back with another presentation. Exactly what it is, we don't know yet, but we'll try to figure that out and announce it within the next week or so. Thanks for watching.